The system used to trigger our machine is something we didn't see in any others. As we found out during the semester, having a simple design that's easy to maintain is more important than having one whose mechanism is visually appealing. In the past, we attempted to use rubber bands or mouse traps held in place by a solenoid, but we experienced problems with these systems because the pulling force against the solenoid was not great enough to overcome the force pushing against it. To counter this issue, our last two machines used pneumatic pistons instead, mostly because of the greater force they produce. In this mechanism, pins are placed into eye hooks on the platform and tied to the moving end of the piston using strings. Because of its orientation, the movement of the piston pulls its two pins from the eye hooks, simultaneously releasing both the platform and the swinging rock arm. To make sure this happens consistently, the solenoid valve controlling the flow of pressurized air is opened and closed 3 times when the track is started. In the past, we've also had problems with wire management, which in some cases stop the drawer sides from fully extending. To make sure we don't have to worry about avoidable issues such as this, we spent a lot of time making sure the wires are well organized. Before being threaded through the flexible cable chain, the wires were strung through eye hooks to make sure they didn't move. The cable chain ensures all the wires running from the base to the platform stay out of the way and don't cause any problems.
Alright, so our rock clearing system consisted of a fixed arm design and a swinging arm design. We had 2 fixed arms on the platform that were on the left and right side so that it would clear the left and right rocks next to the lunar module, and our swinging rock arm was designed to be powered by rubber bands and a hinge system in order for it to clear the front rock in front of the lunar module. We decided to go with the system because it's effective and it's simple. Our previous swinging arm design was too complicated because the bearings would provide too much movement and it would miss the front rock completely. And so with this design, we thought with the power of gravity and rubber bands, we could knock all the rocks out of the way and ensure that we get all the points.
Our sensor decoy depositor system went through 2 different variations, a purely mechanical mechanism and another based solely on the mechatronics. The mechanical version was overall too complicated in its design, that is why we decided to make it purely out of mechatronics. For this we used just 2 wooden guides, a pull solenoid, and a long arm button switch, as you can see on the poster right here. The way this works is that the long arm button switch acts as a trigger for the pull solenoid. This will be positioned accordingly depending on which color track we are on. Once the button switch hits an enemy beacon, it will trigger the solenoid and release the sensor decoys inside an enemy ridge zone. The wooden guides on each side will ensure that the sensor decoys follow a straight path into the enemy zone.
The last task is to place the flag on top of the lunar rigid dome. We decided to design a curved arm which rotates with a motor and fits the top of the lunar rigid. Our big challenge on designing this arm was the curvature at which the arm had to be made in order to fit the radius of the dome. In order to fix that issue, we decided to basically take a different approach of the problem and cut the arm in about 1/3 of it and attach these 2 parts with an hinge that basically helps them join together. So this is the arm, and we decided to cut it about 1/3 to make sure that no matter how long the motor is rotating, the arm always fits the curvature of the dome.